A lighthouse is located on a small island 6 kilometers away from the nearest shoreline. The lighthouse makes 6 revolutions per minute. How fast is the beam of light moving along the shoreline when the beam running along the shoreline is 8 kilometers long? Alright, so first step is you're going to find C on your triangle. So you're going to do 6 squared plus 8 squared equals C squared. This is 36 plus 64 is equal to C squared. Take the square root, but when you add these together, it's 100 equals C squared. C is equal to 10. Alright, now back in the word problem, it said it was 6 revolutions per minute. This will be equal to the derivative of theta. So d theta over dt. Alright, and now we have to think about this because our dy dt is what we're trying to find. This here. And our dx dt up this way does not change. So that is equal to 0. So we're going to use trig. We're going to use tangent for this one, which is y over x. Take the quotient rule and the derivative of the left side. So you got secant squared theta d theta dt is equal to v times derivative of u, which is dy dt, minus y dx dt. All this is over v squared. Now we just plug in our numbers. We can find secant squared. It's going to be the hypotenuse over the adjacent side. So we're going to have 10 over 6 squared d theta dt. Alright, so for d theta dt, it's going to be a little tricky because we got to think of our unit circle. So if we make 6 revolutions, it's actually 12 pi. So I'm going to condense this side first. So we got 100 over 36 times 12 pi. And all of this is equal to, we'll plug in our numbers here. So we got x is equal to 6. We need to find dy dt minus 8. And dx dt is equal to 0. All over 6 squared. So we do a little bit more. We got 12 and 36. That'll reduce down to 3 because 36 divided by 12 is 3. So we got 100 over 3 pi is equal to 6 y prime over 36. Keep it, change it, flip it, and everything will reduce down to 200 pi.